it's Mr. Toops, the Jedi Believe, and you're in George Ranch High School in the Always Believe room. And today we're going to solve equations that involve multi-steps with the distributive property. Ho, ho, ho. It is going to be fun. F-U-N, fun, fun, fun. Okay, we're going to write down the 4 steps again. So the first step, remember, is to get rid of parentheses and fractions. So we want to get rid of all the parentheses and fractions. Then we'll just have letters and numbers. Step 2 is to combine the variables, which are your letters, right? Step 3 is to combine the constants. And lastly, step 4, you're going to divide the coefficient. Last step you do is divide. And I wish I could write better, but that's what you got, okay? So we're going to get rid of the parentheses and fractions. Score! Mr. Toops loves fractions. Then we're going to combine the variables, which are the letters. Usually we use x because x will be the x-axis. Then we're going to combine the constants, and then we're going to divide the coefficient. Now then, if you want to fill in the blank, this is add or subtract. Like terms if necessary. Then collect all the variables on one side. Collect all the constants on the other side. And then solve the equation. Okay? Okay, now then, most equations have one solution. Okay, that means you get like x equals 5. So only one equation will make it true. An example would be 2x plus 3 equals, let's do 9. So what can I multiply 2 by? Add 3 and get it 9. If I subtract 3, I'll get 6. Divide by 2, I'll get 3, won't I? So x will equal to 3. Okay, most equations have one solution. Most equations have no solution. Okay, the other one is no solution. Okay, in no solution, there is not a value that will make the equation true. An example of this would be, let me think here, let's do 2x plus 5 equals 2x plus 3. Notice I have 2x plus 5. I'll zoom in here for you. 2x plus 5 equals 2x plus 3. Today we're going to learn equations with variables on both sides. We want to move the smaller letter. So let's move the 2x over. And what's going to happen when we move the 2x's over? If the x's cancel out, something's going to happen. Okay, so these two right here, the x's cancel out. Or the variable. Let's put variables. Variables cancel out. If the variables cancel out, something special is going to happen. Right here, we would have 5 equal 3, wouldn't we? Since 5 does not equal 3, if you write down false, it's going to be no solution. That means nothing you can put in here will work. And it makes sense. You can't multiply something by 2, add 5, multiply something by 2 and add 3 and get the same answer, can you? That will never ever happen. So no solution to this equation. The other thing that could happen would be all real numbers. Okay? So in this one, any real number will make the solution true. Okay? There are, and I guess this is infinite solutions. Okay, so infinite solutions, and you would put all real numbers. That's 2 ways you could write it. So you could write down infinite solutions or all, and use a capital R for real. Okay, an example would be 2x plus 5 equals 2x plus 5. Notice the left is exactly the same as the right in it. So if I were to move over my 2x, it would cancel out, and I would get 5 equal to 5. If you write down true, then it's going to be all real numbers. And let me change that to real up here. Okay, so all real numbers. So 3 things could happen, okay? You could get one solution, you could get no solutions, or you could get all real numbers, okay? So let's do these problems. Question number 1. Notice there's letters on both sides in it. Move the smallest letter, and I'll show you why right now. The smallest letter here, which one's smaller, 7 or 4? Excellent, it's going to be 4 in it. So I'm going to take this 4 and move it across, aren't I? So the opposite of plus 4 is minus 4. Now then, what's 7 minus 4? Correct, it's going to be a positive 3k. Plus 2 equals negative 10. If I were to move the 7 to the right, I would do 4 minus 7, I would get a negative, wouldn't I? So we always want to try to keep the letter positive. Now then, this is, like I said before, this is what all equations will end up looking like. Almost every single equation is going to be a gx plus s equal total. We're going to talk about that in a minute. Okay? So we have 3k plus 2 equal negative 10. Now then, my phone's ringing, I'm going to keep teaching. Let's solve this. So if you solve this, the first thing you want to do is type in the calculator this number. So you would type in negative 2. Now then, I'm going to move the 2 over. So negative 2 minus 10 is a negative 12, isn't it? Okay. Now then, leave that there, write down 3k equal, and then divide by 3. So on your calculator, you're going to punch negative 2, you'll subtract the 2, then you'll divide by the number in front of the letter. And negative 12 divided by 3 would be negative 4, wouldn't it? Piece of cake. Let's go to question number 2. On question number 2, which one is the smallest letter? Is 5 smaller or 2? Excellent. The 2 would be smaller, wouldn't it? So we're going to take the 2, move it across. What's 5x minus 2x? That's right, it's 3x. Plus 2 equals 14. Now then, the same thing. You're going to type this number first into the calculator. So type in 14, and then you got to move that 2 over. So 14, the opposite of plus 2 is minus 2. 14 minus 2, write down what's on your calculator. You get 12. Then drop the 3x down, and then divide by 3. And I would get 12 divided by 3 would be 4. Okay, so one more time on the calculator. You type this number in first. You move this number across, and you type this in and hit enter. Then you hit divide by the coefficient, and bam, you got the answer. So you're going to add or subtract, get the answer on the calculator, hit divide by, and put the coefficient in, you got your answer. I need to see these steps on your test for you to get credit. Let's go to question number 3. Question number 3 has a fraction. Fractions rule, and we're going to distribute it, right? So we got a double doozy. We got a fraction, that's a bluebell truck. So we're going to take the 1/2 and we're going to distribute it. We're going to drive our bluebell truck to the 1/2 for the 10 and the 40, aren't we? So the 1/2 goes away because we distributed. What's 1/2 of 10? That's right, it's 5. So I have 5x. 1/2 of 40 is 20, plus 20 equals x plus 2x plus 6. So I have, this only has a letter and a number, doesn't it? Over here I have 2 letters. So I need to group those letters together. So 5x plus 20 equals 1x plus 2x, excellent, is 3x, plus 6. Now then, I'm here, aren't I? I'm almost to the point where I can use a calculator. I've got to take this 3x and move it over because 5 is more than 3. Move the smallest x. So I'm going to subtract 3x. 5x minus 3x is 2x, plus 20 equals 6. Now then, on this right here, this is what the equations will look like. We'll use our calculator. So that's the first number we type into the calculator. Then we're going to move the 20 over. So on your calculator, you're not going to do 6 plus 20. You'll do 6 minus 20, hit enter. Your calculator should give you negative 14. Then you drop your 2x. Now we're going to divide by 2, and we'll get x equal. If you do negative 14 divided by 2 on the calculator, you'll get negative 7. I need to see these steps. Oh, That's more power. If you're watching online, you can pause and like catch up, okay? I'm going to try to make these videos as short as I can because I don't want you watching 40 minutes of video. Okay, let's go to the next question. On the next one, our Bluebell truck is right here. It's a 3. So I'm going to distribute the 3. 3 times 4b is 12b. Minus 6 equals negative 6 plus 12b. Okay, now then I've got to move by letter. Notice the letters are exactly the same, aren't they? This is what's going to happen here. We're going to take the 12b, move it across, and the 12b's cancel out, don't they? So I have negative 6 equals negative 6. There's no more letters, so is this true or false? You would write down true, and the answer would be all real numbers. The test may say, some tests may say infinitely many solutions. Okay, so on your STAR test, they could have all real numbers or it could have infinitely many solutions. That's what happens when it works out to be the same. Let's turn the page. Okay, question number 5. This is so much fun. Question number 5, we're going to move our Bluebell truck, which is the 2. So I'm going to distribute the 2. Let me zoom in more so you can see better. So we're going to have 10z plus 12 equals 2 times 5 is 10z plus 12 again, aren't I? So if I move this 10z to the left, what's going to happen to my z's? They cancel out, right? So I'm going to get 12 equal 12. That's true. Since it's true, all real numbers. So if your letters cancel out and you write down true, you'll write down all real numbers. If the letters cancel out and these are not equal, it will be no solution. Ho, ho, ho. Let's go to question number 6. Question number 6. Okay, this has a letter and a number, but this side has 2 letters, right? So we got to group them up. So 3y minus 5 equals 1y plus 2y is 3y, but I have minus 9, don't I? So the y's are the same, right? When I move this y over, the y's will cancel, won't they? So I'm going to have negative 5 equal negative 9. Is that true? That is not true, is it? So you would write down false, and if you write down false, you're going to put no solution. Ho, 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 ho. So if it's true, all real numbers. If it's false, no solution. Don't turn the page, and let's go to the next problem. There's so much fun. Okay, on this problem, notice we have a letter and a number over here, but over here we have 2 letters, don't we? So we got to group those letters. So 9m minus 4 equals negative 3 plus 12. Which one do you have more of, 12s or 3s? You have more 12s, so it's positive, and these are different signs, so you'll subtract. 3 away from 12 is 9, and our letter's M. Sign, number, letter. You're still doing that. And then plus 5. Notice on this one, and I'm just going to scratch them out. If I were to move that 9m over, it would cancel out, wouldn't it? And I would have negative 4 equals 5. Would I write down true or false? That is not true, is it? If you write down false, you put no solution. If you write down true, it's all real numbers. Oh, let's go to question 8. Remember, you can pause, if you're watching this on video, you can pause it to catch up. Okay. Question number 8. Let's do our Bluebell truck. I love Bluebell trucks. So we're going to distribute the 2. We're going to get 2y plus 4 equals 2y plus 4. Notice it's exactly the same in it. So the 2y's are going to cancel out, correct? And I'll have 4 equal 4. That's true. If you write down true, it's all real numbers. That means any number you put in there is going to work. Oh. What a blast. So do y'all see what happens if your letters cancel out? Okay, it's either going to be all real numbers or no solution. Okay, let's go to question number 9. Now then on question number 9, this is a classic GX plus S problem. Okay, let's read this first sentence and underline this part and tell me what the starting number and the growing number is. One printing company will print cards for 10 cents each. That's going to grow our cost, right? Plus a setup charge of 15. That's our starting number. So put S and G. I'm sorry. Yeah, S and G. Now then the other company is 15 cents a card. It's more money in it. That's going to be our growing number. But the setup, but with a different, if 100 business cards, what is the setup charge for this? Okay, so we do not know the setup charge, so we do not know this starting number here. So the starting number is going to be X in it. Okay, and we know that we're going to have 100 business cards, right? So the 100 is going to go into this X. So let's set this up. We're going to have 0.10x plus 15 equals 0.15x plus something we don't know, right? We don't know what this cost is. So we know that we're going to get 100 business cards. So let's put 100 in here. 0.10 times 100 plus 15 equals 0.15 times 100 plus, and let's make this y. So we want to find the starting cost of this, right? Now then, 100 times 0.1 is 10 plus 15 equals, and 0.15 times 100, or 15 hundredths times 100 is 15 plus y. I'm going to put it over here. 25 equals 15 plus y. I'm going to move my 15 over, and I'll get 10 equals y. Okay, so we're going to set up our gx plus s equations. We don't know the startup cost, but we know we're getting 100 business cards, so we're going to plug 100 in for x, and we're going to let this number be y. After we do the arithmetic, we get 10 plus 15 equals 15 plus y. Basically, the 15s cancel out, don't they? And you would get y equal 10. So this startup fee would be $10, wouldn't it? Let's go to number 10. What a blast. This is another gx plus s problem, okay? Okay, so if the hairdresser chooses location A, she will pay $1,200 per month in rent and charge $45 for haircut. So we're only doing 1 month here. So this right here is going to grow our monthly bill, and this is what we pay to start off our monthly bill. So this would be our gx plus s. Now then on this one, notice the startup price is more, but it's more for this too, isn't it? Okay? So this will be our starting number, and this will be our growing number. Okay, so right here, okay, this needs to be flipped. Let's make this one 60 and this one 45, or it won't work, okay? So make this number 60, make this number 45. So our gx plus s will be 60x plus 1,200 equals, this will be 45x plus 1,800. Okay, so this one costs less to start off, but you're charging more. You pay more for here, but you're going to charge less. So when will this even out, okay? So what's the smallest x? The smallest x is 45. So 15x plus 1,200 equals 1,800. And then I'll move the 1,200 over. Now then on your calculator, you're going to punch 1,800, subtract 1,200, you'll get 15x equals 600. And on your calculator, you're just going to hit divide by 15, and you would get 40. So after 40 haircuts, it's equal. So how many haircuts would it take to make the same? 40 haircuts would be the same. I hope you have enjoyed the day. You're going to have a test soon over this. You're going to do well. And remember, always believe, and you are awesome.